Hello, 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 and welcome to week 9 of Health Statistics HIT 500. Now, we are getting very close to being done with this particular course, and you all are working so hard. Do not stop. Let's keep pushing hard to the finish line. There are a few things we know we have to complete, right? Knowledge checks. I will be sending out emails for everyone who has not had the opportunity to complete them on Thursday. Remember that you are trying to get a score of at least a 90%. So take it as many times as you can. And even when you get that 90%, do it again. See if you can get 100. Work on your apply and reflection. This is going to definitely help you as you prepare for your weekly feedback. As you know, our feedback is due every Sunday, and you have till 11:59. Now, this week, we do take a break from working out problems. We will be talking a lot about data in general and then the types of data. One thing that we do almost every day without even thinking about it is use some type of data from ordinal, interval, nominal, and even ratio. So this week, for the discussion forum, here's the scenario. You're about to purchase a 2023 Tesla SUV. What are your considerations before your purchase? Think in terms of data. We're going to discuss the types of data in the live session tonight. So jot down some key points of each one so we can discuss it in the forum. Now, my computer is acting a little crazy. So you saw this slide a little earlier, and that's okay. What was the number 0 originally called? It was called cipher. Now, cipher comes from the Arabic word cipher, meaning empty. The first known use of the word 0 was in 1958. And from Albert Einstein, pure mathematics is, in its way, the poetry of logical ideas. All right, now on to our chapter. Now keep in mind, we are getting a break from doing a lot of math work. Okay, but that doesn't mean that we lighten up. We're going to continue to push hard. Let's get into some show and tell when we talk about presentation of data. So these are our learning objectives. We're going to explain, differentiate, and apply the following terms: nominal, ordinal, interval, and ratio, as well as discrete and continuous data. We're going to talk about creating tables and graphs to display statistical information. We're going to distinguish between tables and different graphs: bar graphs, pie graphs, line graphs, histograms, frequency polygons, pictograms, and scatter diagrams. And then we're going to look at preparing the basic elements of a report. We're going to go ahead and jump right in with types of data. Now, as you can see, the most common type of statistics that the health information technician will encounter or be responsible for producing is going to look at the population that they're dealing with, meaning what type of patients are you going to have in your type of facility? Are you going to be a trauma 1 hospital, or are you going to be a plastic office place, right? With that, what services are you going to provide? In a big hospital, you will need multiple units, as opposed to a surgery center or an office where you may only need a small little recovering area just so the patients can be ready within, those typical day surgeries, procedures. Now, you look at the overview of different features, and we talk about it in a set of data. We can assume that a number of different forms, tables, and graphs. Now, the very first thing we're going to look at is categorical data. When we mention categorical data, we are talking about nominal scale, okay? The first one you see, nominal scale. It's really like a naming scale where variables are simply named or labeled with no specific order. You have the lowest level of measurements. Nominal means pertaining to a name. So you have observations organized into different categories. For example, when you're going to take your feedback, you may have some true and false questions, right? If you're going to fill out demographics, you may have male or female. If you are filling out your insurance for a procedure, you may have types of insurance carriers and what do you do for a living? So they may ask you for like the patient's occupations. Numbers may be used to actually represent these categories. This is why I really like this particular slide because it kind of breaks it down. You have your multi-class classifications. You have your nominal, meaning like your movies, hair colors, religion. These are other different ones. And then your ordinal, the ratings of the movies, your pain score on a scale of 1 to 10, or functionality. Now, other things about the ordinal scale is that it has a lot of variables in a specific order beyond just naming them, all right? So you have your interval scale offers labels and orders as well as specific intervals between each of its variable options. Values are in ordered categories. Ordinal means to put into order. So the order of the number is meaningful, not the number itself. For intervals or distance between categories are not necessarily going to be equal. So here's an example. You have head injuries. They can be classified according to the level of severity, where 4 is fatal, 3 is severe, 2 is moderate, and 1 is minor. A neutral order exists among the groupings. The largest number represents the most severe level of injury. The order could be revised. Intervals between ordered categories are not assumed to necessarily be equal, all right? Keep that in mind. We move on to numerical data. Now, numerical data refers to the data that is in the form of numbers and not in any languages or descriptive form. It's often referred to as a quantitative data. Numerical data is collected in number form and stands different from any form of number data types due to its ability to be statistically and arithmetically calculated. All right. We move on to our interval data. Remember, we're talking about types of data. Now, interval data, also called an integer, is defined as data which is measured along a scale, in which each point is placed at equal distance from one another. Examples would be Celsius or Fahrenheit, marking your grades, your IQ tests, and something that we look at, your GPAs. It includes units of equal zeros, but there's no 0 point. For example, we talk about temperature in Fahrenheit degrees. So the interval between the values are the same. The most important characteristic is that the intervals between values are equal. All right. I will repeat that last part. The most important characteristic is that the intervals between the values are equal. Now, when we look at ratio data, we are looking at the difference between interval and ratio data being simple. Ratio data has been defined as a 0 point. Income, height, although a lot of us want our income to be larger, weight. A lot of us like our weight to be lower. Annual sales, market shares, product defect rates, time to repurchase. You have an item, you go to Best Buy, they give you a certain amount of time where you can return it for full refund. Unemployment rates, crime rates, these are all examples of ratio data. It may be displayed by units of equal size, placed on a scale starting with zeros, and can be manipulated mathematically, such like a 0, a 5, 10, 15, and 20. We'll look at age, all right? The difference between any 2 years would be the same, like the difference between the age 1 and 2 is 1 year. The difference between age 55 and 56 is 1 year. And you can go on and on, right? There is a 0 point, and that 0 would mean an absence of age or birth. You were born. So from 30 to 31, that's a year. Now, someone that's like 100 years old is twice as old as someone who's 50 years old, right? Because 50 and 50 is 100. Continuing on with numerical data. Here, I want to bring up an example of the number of children in a family. A family can have 2 or 3 children, right? But you cannot have 2.25 or 3.5 or 5.12, right? You have the number or none. So this is where they mean where they can have only specified values. You can have 1.2 pet, right? So you're looking at, here's a family of 5, they a mom, 2 parents, 3 children. Here are other examples that we look at. So the number represents actual measurable quantities rather than labels. When we're talking about, and we're not having to figure any of this out, but you have your mean, your standard deviation. So the number of motor vehicle accidents is a particularly community, right? Besides here, maybe the number of times a woman has given birth, the number of new cases of cancer cases in your state within the past 5 years, and the number of beds available in your hospital. These are all different examples of actual measurable quantities rather than just labels, okay? We talk about a natural order that exists among possible values, okay? We look at the difference between 1 and 2 births is the same as the difference between 4 and 5. The number of births is restricted to, of course, whole numbers. A woman cannot give birth 2.3 times. Moving to continuous data. It can take on a fractional value, as you can see. All right. For example, a patient's temperature may be 101, 102, 103.5. Height. One could say that someone is approximately 6 feet tall and then refine it to 5 feet 10 inches and refine it even more and be like, you know what? I'm 5'10 and a half, 3/4. People want to make sure we get those extra. Every little bit counts when we're talking about our height. And then if you take it another step and look at age, you may have been 20 years old on your last birthday, but you are 20 plus some part of another year, right? 20, my little one likes to be like, oh, it's my half birthday. Okay, all right. The 6-month point before the next celebration of year. We look at our limiting factors or continuous observations in the degree of how accurate they are. When we talk about analysis, you're looking at continuous data, often that is being converted to a range that acts as a category. And here we're looking at accuracy, right? This one's going to be precise, it's accurate. This one is also precise, but if you notice, it's not necessarily in the bullseye. Imprecise, well, look, everything is pretty accurate where they wanted it to be. And then you can have imprecise and inaccurate. You're just all over the place. Now, age can be categorized in ranges from like 0 to 20, 21 to 30, 31 to 40. You guys get that, right? Now, measurement on the interval and ratio can be grouped. Interval and ratio variables are continuous, okay? So that's great. That's the information. But how do we display it so that we can actually look at it, right? Well, we may have tables. Almost any type of quantitative information can be grouped into tables. Columns really allow us to read the data. We can look at it up and down. We can go by rows, and you can actually see what's in the rows. The biggest thing is these columns and rows need to be labeled. Imagine just having a whole bunch of information on there and, okay, decipher, right? It's not gonna be that easy. So having it labeled really helps us to identify the information that we are analyzing. More information can actually be presented, right? Values can be listed as it says. You can have supportive information. Less work, fewer costs are required because you're putting it all there in the preparation. And you want to look at maintaining that flexibility without really distorting the information. So, like you go and you have a picture, but you want to get in really close, but the more you bring in the pixels, it becomes distorted, right? You don't want that. So you want to be able to keep it more fluid so that it's flexible. There are essential components of tables, okay? So we know that they need to be labeled, right? We know that we can look at them up and down. But when we look at the components, you have your table numbers. You use table numbers, especially in professional reports. This helps to identify the table, and it's referenced in the body of the report. You want to know what it is. So you have a title. This is going to explain as simply as possible what is contained in the title. You may have a head note or a short explanatory note that applies to the values in the table, just like right under the table. Your caption. This is going to refer to the headings of the columns, something brief and something that can be explained by just looking at it. So it's self-explanatory. You have your subs, categories on the left-hand column of the table. You have your body, information that's going to be formed by intersecting columns and rows. Your footnotes, source footnotes. This is going to be the source for any data, and it should be identified in a footnote, okay? The data display is going to show values. And you can take any number of the observation associated with each value. You see here where you talk about a variable being a characteristic or property that may take on different values. You see what these values could be: third-party payers, discharge services. When did they come in? When was their actual admission day? Now, besides knowing exactly what goes onto the table, we have certain types. For example, our frequency distribution table. Here, the general rule is choosing the class or category in which the data is going to be grouped and the range of each. Now, you do not use fewer than 5 or more than 15 categories because you don't want it to be too crazy, too big. The categories need to be defined. Categories should mutually be exclusive, where each observation is going to be grouped in each category and only each category. And then when possible, make the classes cover equal ranges or intervals of values. All right. Now let's get into other ways we look at different things, especially data, right? Graphs. Now, with these graphs, besides what you see, they should be easy to read. No one wants to pull up a graph and it's so complex that you're getting a headache because you just can't figure out what's going on. So the content should be simple and everything should be correctly labeled. Okay. Now there are some guidelines for creating graphs. The graph itself must relate to what the graph shows, again, as simple as possible. We use when we are including 2 or more variables, and then the category should be neutral. The vertical axis should always start with a 0, right? Around here at the 0. The scale of values for the X reads from the lowest value on the left to the highest value on the right. So we're going higher as we move to the right. And then the scale of values of the Y axis extends from the lowest value at the bottom of the graph to the highest at the top. Other things we look at scale captions. These are, like you see, titles. They're placed on each axis. We want things to be easy on our eyes. When we are looking at a lot of information, you could get fatigued, but having it so that it makes sense does help it make it easier to read. And then you look at your exact reference to outside sources, making sure you give credit to where you're getting this information from. Okay. Let's move into bar graphs. Bar graphs are also called bar charts. The simplest bar graph is a 1 variable bar. The various categories of observations are presented along a horizontal or x-axis. The vertical or y-axis displays the frequency of the data. Data representing frequencies, proportions, or percentages of categories are often used with these type of graphs. Now, a grouped bar chart is used to display information from tables containing 2 or 3 variables. Well, that's a bar chart. When we look at the pie chart, we're talking about a circle divided into sections, like wedges of a slice of pizza. The sizes of the slices of the pie show the proportional contribution of each part. The percentages of the total is going to equal 100. Data does have to be converted to percentages. Pie chart wedges may be shaded or colored like you see to help kind of show the different sections of the wedge. Additionally, they can be cut out of the pie to help emphasize the amount of percentages. Like this one, it is 3D, which is kind of cool, but they are still cut out and the colors change to kind of show you. And you can see almost like in the back, granted, we don't have all the information, but you can see the amount of percentage each section is to the whole. The line graph. All right, so this is used to show data over time, days, weeks, months, or even years. The x-axis shows the time period, where the y-axis shows the variables. Now, this consists of lines connecting a series of points on an arithmetic scale. It also allows for several variables, as you can see, to be plotted. It may be referred to as a running chart in quality management studies. Oh, that was pretty interesting information. Histograms. Now, the difference from a bar graph is that bar graphs display data that falls into categories. Histograms illustrate frequency distribution of continuous variables. Histograms are created from frequency tables, all right? And as you can see, It says that it's a representation that is used to display frequency for continuous numerical data. What they're saying is this is going to be interval or ratio data. Now you have your bars, right? They should be of equal width. There should not be less than 4. And I know this one shows a lot. And usually never more than 12 bars or classes. And the frequency groups should never overlap. Now, our next data display is a frequency polygon. Now, with this, a frequency polygon is a visual representation of a distribution. The visualization tool is used to understand the shape of distribution. Essentially, the frequency polygon indicates the number of occurrences for each distinct class in that particular data set. They may be used instead of a histogram. It is similar to histogram in that a graph is depicting frequency of continuous data, but a frequency polygon in line form instead of a bar form, okay? Now, advantage is that several can be placed on the same graph to make comparisons. It uses the same axis as the histogram. That is that the X displays the scale of the variable, all right? This is gonna be your variable. And the Y displays the frequency. A dot is then placed at the midpoint of the class interval or the frequency. And then these dots can be connected by a line, right? By a line drawn from one point to the next. Because the X represents the entire frequency distribution, the line starts at 0 cases and is drawn from the last frequency to the axis to end back with 0. So you're looking at frequency, all right? A pictogram, so you're looking at pictures. You are seeing different things, and as you're watching, a lot of these you can actually pick out, you know what they are because of the symbol. Well, a pictogram is a symbol that conveys meaning through its resemblance to a physical object. If you wanted to show the number of individuals who can use stick people, you can use a pictogram. It can be very entertaining. And what these do is it catches the attention of whoever your audience is, all right? Next, we look at our scatter diagram or scatter plot. Now, a scatter diagram is used to examine the relationship between both the X and Y axis with one variable. In the graph, if the variables are correlated, then the point drops along a curve or a line. Now, a scatter diagram or scatter plot gives an idea of the nature of the particular relationship. So you're looking at a correlation implying that one variable changes, the other also changes. This does not always mean now that there is a cause and effect relationship between the two variables, because there may be other variables that can cause that change, like an outside variable coming in and causing that change. If the two characteristics are somewhat related, the platform of points will show tight clustering in a certain direction. The closer the points look like a line in appearance, the more the two characteristics are likely to be correlated. The slope of the line can be either positive or negative. A positive would be small values of the x-axis correspond to small values of the y-axis, and large values of the x-axis correspond to large values of the y-axis, meaning that there is a positive linear relationship. On the other hand, if you have a negative line, then the small values of the x correspond to larger values, and large values of the x correspond to smaller values of the x. That is when you're looking at a negative linear relationship. But this is great. Now we need to actually prepare our report. We have the types of information that we're going to look at. We have the types of data that we're going to work with. We know how we're going to display this data. Now we put it all together. So when we prepare our report, we look at, I always say communication is the key, but it's really a goal as well. We're talking about who are we getting this report for? Are we preparing it for stakeholders? Are we preparing it for our physicians? Are we preparing it for our nursing and our ancillary staff, right? We also look at healthcare administration usually dictates how these reports are prepared and how they're going to be presented to the particular facility. You review previous reports that have been given to committees or administration, and they use that as a guide to kind of show, okay, so this is what we looked at last time. This is where we're moving forward to. All right, we have a game plan. The last part of this particular chapter talks about the actual general guidelines. So you see it says it's going to include a title for the report. Got it. We have formal reports. They're going to have graphs. They're going to have tables, as well as a table of context, so that we know exactly where to go if there's something in particular we want to read on and research. Formal reports do include, this is what this is about. This is your introduction, and includes the table and the graphs. Now, the tables show summarizations and they have a lot more detailed data. Graphs are useful for presentations because it helps to give that visual aid to your content. Once you determine the type of audience, this is going to help to decide what to include or omit in your report, because it's going to be relevant to that particular audience. When we prepare a narrative report, you need to have a more understanding of what's going on in that report, because narratives include historical data in some cases. It can include factors that may influence the data, such as seasonal changes in the population, or reasons for significant increase, or why there has been a decrease in the data that may have been in previous reports. With that, we're still including our source of the data, where we got it from, and you want to make sure this information is correct, especially if it's being presented to the stakeholders, the upper echelon in your facility. So with that, you want to proofread, and proofread again that report for your accuracy. All right. Well, that is chapter 11 in a nutshell. As we move closer and closer to completing this module, I want you to know that you've got this. Super proud of y'all. The light is getting so much wider and our tunnel is getting smaller. Your apply and reflect, there are just 9 multiple choice questions. Your some of the questions you may see, as you see in front of you, you're creating a bar graph that shows the live discharges and deaths for each service listed, as well as creating a pie chart showing the discharge days for each service. And you submit your 2 graphs created in an Excel spreadsheet. And then you're just going to use that submission box that has been presented to you into Moodle. Now, if anyone has forgotten or needs a refresher on how to create a bar or pie chart, send me a quick email and I will send you a quick video. Remember, we did this back in HIT 410. I know that was eons ago, but the very first week before we got into the VLab, we did do creating charts, all right? You still have your knowledge check, and I pulled 2 random questions that I'm just going to go over really quick and see how well you do. Which of the following graphs would be best for the cancer registrar to use to display the 10-year survival rates of breast cancer patients at your hospital? Is it A, a bar graph, B, a histogram, C, a frequency polygon, or D, a line graph? So I'll give you a couple to kind of look it over. Question: which of the following graphs would be best for the cancer registrar to use to display the 10-year survival rate of breast cancer patients at your hospital? Bar graph, histogram, frequency polygon, or a line graph? The correct answer would be a line graph. Next question. A graph depicting the frequency of continuous data. However, a frequency polygon is in line form instead of a bar form. This is a bad question because you have discrete data, interval data, frequency polygon, and a histogram. The correct answer is actually in the question, a frequency polygon. All right, I hope you guys are feeling comfortable with that. Keep in mind, you do have your apply and reflect again, all right? 9 multiple choice questions. Just to recap for everyone watching the playback, here is our discussion forum question. One thing that we do almost every day without even thinking about is using some type of data from ordinal, interval, nominal, and even ratio. You are about to purchase a 2023 Tesla SUV. What are your considerations before your purchase? Think in terms of data. We discussed the different types in the live session tonight. Go back and reference the types so that we can discuss it in the forum. Your math trivia. What was the number 0 originally called? Remember, it was called a cipher. Cipher comes from the Arabic word cipher, S-I-F-R, meaning empty. The very first known use of the word 0 was in 1958. And pure mathematics, in its way, is the poetry of logical ideas. We went over chapter 11. We talked a lot about presentation of data. We started off with just breaking down the types of data. We continued and moved on to how that particular data is displayed, the different graphs that we use. And we finished up with preparing the reports and having that information, most importantly, accurate before we submit it for presentation. Don't forget to work on your apply and reflect. Your knowledge checks, the goal is to score at least a 90% or higher. I will be sending out emails on Thursday just to remind you, hey, keep moving if you haven't gotten to them yet. And this is our wrap up. If you find that you do have a question on anything or something doesn't seem right, something needs to be opened, please do not hesitate to reach out. We have 2 weeks left, full weeks after this week, and then we're on a break. So have a wonderful Labor Day weekend. It's my birthday. So be safe, stay cool, drink water, and I will see you all next week. Bye.